Right. Okay. Good afternoon, everyone. Can you all hear me?
Yes, sir.
Right. Okay. So, I am going to do the second phase of the seminar, which is relevant to the sampling and inferential statistics part. Right. So, when we are talking about the sampling and inferential statistics part, so most of the students say that the questions, especially in the MCQ paper, most of the questions are problematic or little bit complex, especially comparing to the other lessons. So therefore, we think it is beneficial if we can discuss some key concepts in the sampling and also in inferential statistics. So actually in this phase, I am going to first discuss the MCQ part, right? So this model paper was shared with you, I think, last day. Hope you may try to answer the questions in this model paper. So normally, you know that, right? MCQ paper consists 50 questions and around 15, 16 questions are coming from sampling part and inferential statistics part. So if you are talking about the inferential statistics part, there are three main areas as sampling distributions, estimation, and hypothesis testing. So my personal belief is if we have good understanding about the concepts of sampling and sampling distribution and estimation, as well as in hypothesis testing, actually the MCQ paper is not much difficult that most of the students think. So anyway, in this session, I try my best to give some directions to identify how we can select the correct answers for MCQ questions, especially in sampling and inferential statistics part. So in this model paper, I think up to 10th question, they are related to the probability and probability distribution part. So actually in the earlier phase, there is not much time to complete the entire paper. So anyway, in the future, you can find the answers for those MCQ questions. Anyway, so I will start the session with this question. So the question is 11th one in your model paper, right? So during the discussion, if you have any questions, you can ask, right? So you can raise your hand, or also you can use the chat box if you have any questions, right? Because use this time as much as possible to as much as possible ways to clear out if you have any questions, especially regarding these lessons, right? So so what is 11th question? Which of the following statement is true? So there are 5 statements. Among those 5 statements, we have to select the correct one. It means there are 4 statements which are incorrect. Let's consider the first statement. Simple random sampling is a method of selecting a sample given each unit in the population with a known probability of being included in the sample. So if you know the definition of simple random sampling, right? If you know the definition of simple random sampling, then you can identify whether the particular statement is correct or incorrect. So what is the definition of simple random sampling? When we are defining simple random sampling, we say we select a sample giving each unit in the population with a known and equal probability, right? So when we are doing simple random sampling in the population, for each unit has a same probability of being included in the sample, not only known, right? So the error in this statement is the definition of simple random sampling is not here. Rather, defining simple random sampling, this statement is okay for defining the concept of random sampling. Because if we are defining the random sampling, it means each element in the population has somewhat probability or known probability of being included in the sample. But if you are defining the simple random sampling, the definition is incorrect. So therefore, the first statement is an incorrect one, right? Let's consider the second statement. So in the second statement, it says, without a complete sampling frame, cluster sampling cannot be used, right? Without a complete sampling frame, cluster sampling cannot be used. No. As an advantage of the cluster sampling, you learned that we can use cluster sampling even without a sampling frame, right? Because when we are doing cluster sampling, we are not going to select one by one element from the population. The population may be consist of clusters, artificially or naturally. What we do, we select one or more clusters randomly that represent the population. So therefore, we are not interested a sampling frame in the cluster sampling. So therefore, even there is no any sampling frame, we can perform cluster sampling. So actually it is advantage of the cluster sampling when comparing to the other sampling techniques like simple random sampling, stratified random sampling, and systematic sampling, right? It's an advantage of the cluster sampling. So therefore, the second statement is also incorrect. This is also incorrect. Let's consider the third one. Auto sampling is an example of semi-probability sampling. So normally there is a classification of sampling techniques as probability sampling and non-probability sampling, right? Or we say random sampling and non-random sampling. So there are 4 types of random sampling techniques, mainly as SRS, stratified, systematic, and cluster. And also there are some non-random sampling techniques as well as judgment, convenience, snowball, and so on. Anyway, there are some sampling techniques which have both features of random sampling as well as non-random sampling. So in your syllabus, there is a one sampling technique that is considered as a semi-probability sampling, but it is not auto sampling, right? It is systematic sampling. So actually, auto sampling is a 100% non-probability sampling technique. We are not considered it as a semi-probability sampling. We consider systematic sampling as a semi-probability sampling, because in systematic sampling, when we are select the first element, it means the random starter. It is the only one element that we select randomly. All other are select based on that random starter. So therefore, both random and non-random features are mixed with systematic sampling technique. So therefore, auto sampling is a totally non-probability sampling technique, not a semi-probability sampling technique. So therefore, third statement is also incorrect, right? So first one is incorrect, second one is incorrect, and also the third one is incorrect. And consider the fourth one, the finite population correction factor may be ignored when it is close to zero. So as an example, if we consider the variance of x bar, right? Let's consider the variance of x bar. So you know that, right? X bar is the sample mean. And when we consider variance x bar, we can calculate it by sigma squared divided by simple n. In addition to that, if the population size is known, right? Population size is known, you can also consider the finite population correction factor as this, right? So this is called, this part is called as the finite population correction factor. So the idea is, using that factor, if we can reduce the variance, then it is good thing. When we are doing estimation or any statistical thing, if we can reduce the error or the variance, it is always good. So here we consider that using this finite population correction factor, can we reduce the variance of x bar? So if the value is close to zero, what happens? Assume that capital N minus simple n divided by capital N minus 1 is close to zero. So what happened to the entire part? What happened? It is also goes to zero. It is also goes to zero. So in that kind of situation, can we ignore the factor? Our objective is to reduce the variance of x bar. And the finite population correction factor in this case close to zero. Such situation, we are going to ignore the factor. Is it correct? No, it is not correct. There are some times we can ignore. What is that time? If the finite population correction factor is close to 1, then there is no any change for the variance. Right? Thank you. මෙතන තියෙන මේ finite population correction factor එක බිඳුවට යනකොට variance එකට impact එකක් තියෙනවා. Because variance is also going to be reduced. But if the finite population correction factor is close to 1, there is no any change. So therefore, in such situation, we can ignore the factor. Right? So the fourth statement is also incorrect. Why? We can't ignore the population correction factor when it is close to zero. We can only ignore when it is close to 1. So the error is here. So therefore, fourth statement is also incorrect. So therefore, now you have the choice for the correct choice. That is fifth one. What it express cluster sampling is more effective if variation within the cluster is large. Within the cluster, the variation is large. So that is the objective of doing cluster sampling, right? Within the clusters, variation is large. In between clusters, variation is small. Then cluster sampling is more precise than other sampling techniques, especially with stratified random sampling. So therefore, if you have clusters, within those clusters, the items are heterogeneous or their variation is large, then cluster sampling is more effective. So therefore, fifth statement is a correct one, right? So that's how we select the correct statement or the answer for the question number 11. Okay, let's move to the next question. 12th one, right? 12. So here also we need to select the correct one or which of the following statement is true. So there are also 5 statements. Let's consider the first one. If the variation between strata is large, the precision of stratified random sampling is small. If the variation between strata is large, the precision of stratified random sampling is small? No. Precision is increased, right? Why? Because the variation in between stratas is large. Stratas are heterogeneous. නේද? පිට තියෙන ස්ට්‍රාටා ටික එකිනෙකට වෙනස්, විෂමයි. ඒවායේ තියෙන වේරියේෂන් එක වැඩි. ඒ වගේ අවස්ථාවකදී stratified random sampling එකේ precision එක ගොඩක් වැඩි. So therefore, the precision of stratified random sampling is not small but large when the variation between strata is large. So therefore, first statement is incorrect. Then the second one, if intra-class correlation coefficient is close to 1, if intra-class correlation coefficient is close to 1, cluster sampling is more efficient than simple random sampling. So what is the role of intra-class correlation coefficient? Why we need that particular coefficient? So normally, intra-class correlation coefficient measures the homogeneity of the items within the cluster. If we consider a cluster, this is a cluster. Assume cluster 1. So within this cluster, there are different types of items. So these are the items, right? So the intra-class correlation coefficient, consider it as rho. This coefficient measure how much association exists among these elements, the correlation among these elements. And if it is equal to 1, what it implies? Normally we know if the correlation coefficient is equal to 1, it implies that there is a strong perfect positive correlation. It means all items are behave in the same manner. So it actually inverse to the variation. If there is a tight correlation, then the variation is loose. So it means intra-class correlation coefficient indicates these elements are not much varied. They are actually very similar items. It means within the cluster, the variation is very low. So in that kind of situation, cluster sampling is not a good selection. Actually, it is not efficient. So therefore, if the intra-class correlation coefficient is close to 1, simple random sampling is fine. Why? Because within cluster, all the elements are pretty much similar. They are similar. So it means within cluster can observe homogeneous elements. එක වගේ set එකක් ඉන්නේ cluster එක ඇතුලේ. ඉතින් එක වගේ set එකක් ඉන්න වෙලාවක cluster sampling කරන එකේ තේරුමක් නැහැ. ඒ වගේ වෙලාවක SRS ඇති. මොකද SRS කරන්න නම් අපි දන්නවා homogeneous population එකක් තියෙනවා. Right? එහෙනම් දැන් intra-class correlation coefficient එක එකට නෙවෙයි යන්න ඕනේ. ඒක බිඳුව පැත්තට යන්න ඕනේ නේ. If the intra-class correlation coefficient is close to 0, then cluster sampling is efficient. It is more efficient than SRS. So therefore, the second statement is also incorrect, right? Because when intra-class correlation coefficient is close to 1, SRS is more efficient than cluster sampling. Right. Third one. A quarter sampling is usually selected using a sampling frame. Hari? Then make a sampling frame ගැන තියෙන කතාව. So normally we learn that if we want to do a random sampling, except cluster sampling. Hari cluster sampling නැතුව random sampling technique එකක් නම් අපි පාවිච්චි කරන්නේ normally we need a sampling frame. Sampling frame may be a list or a map. Whatever, we need a sampling frame. List of all the items in the population. If you are preferred to do a random sampling. Except cluster sampling, right? Cluster sampling වලට අදාළ නැහැ. නමුත් අනිත් random sampling techniques පාවිච්චි කරනවා නම් sampling frame එකක් සාමාන්‍යයෙන් තියෙන්න ඕනේ. But quarter sampling is not a random sampling technique, right? Quarter sampling is a non-probability sampling technique or non-random sampling technique. So therefore, in order to do quarter sampling, there is no need of sampling frame. Right? So actually, when we are doing a systematic sampling, yes, we need to know the sampling frame. Because in theoretically, first we need to calculate the sampling interval, that is K. So how we calculate K without knowing a sampling frame? So we need to know the list of all the items in the population. But in some practical cases, actually we can use systematic sampling without proper sampling frame. But theoretically, conceptually, in order to perform systematic sampling, we need a sampling frame. Because we need to know each and every item in the population, because in SRS systematic as well as in stratified random sampling, we select items. It is only different with the cluster sampling, because in cluster sampling, we only select clusters, not the items. Anyway, quarter sampling is not a random sampling technique. Therefore, we don't need the sampling frame. So therefore, third statement is incorrect. Let's consider the fourth one. The main purpose of circular systematic sampling, right? So this is regarding the circular systematic sampling. Normally, there are two types of systematic sampling, as linear systematic sampling as well as circular systematic sampling. නේද? පළගෙනගෙන තියෙනවා linear කියලා එකක් තියෙනවා, circular කියලා එකක් තියෙනවා. So the main purpose of circular systematic sampling is to select a systematic sampling when the sampling interval is an integer number. So the error is in here, integer. So actually, the main difference between linear systematic sampling and circular systematic sampling depend on the concept of integer number. So if we calculate the sampling interval means k, right? So I will erase these things. So normally, how you start the systematic sampling? Systematic sampling, you calculate k. K means sampling interval. So how you calculate sampling interval? You divide capital N by simple n. That's how you calculate the sampling interval. So if it is an integer number, right? Integer number කියන්නේ පූර්ණ සංඛ්‍යාවක් වුණොත්, integer එකක් වුණොත්, you can implement linear systematic sampling. පාට කිසි ප්‍රශ්නයක් නැහැ. Linear systematic sampling එකක් කරන්න. But if it is not an integer number, then you have to do a circular systematic sampling. So therefore, the purpose of circular systematic sampling is to select a systematic sample when the sampling interval is not an integer number. If we can find an integer number as the sampling interval, we can do linear systematic sampling. But if we are unable to find an integer number as the sampling interval, then we have to use circular systematic sampling. So therefore, fourth statement is also incorrect. එනිසා දැන් හතරවෙනි statement එකත් වැරදි. First එකත් වැරදි, second එකත් වැරදි, third එකත් වැරදි, fourth එකත් වැරදි. So therefore, you can select fifth one as the answer. පස්වෙනි එක හරි උත්තරේ විදියට ඔයාලට දැන් consider කරන්න පුළුවන්. Anyway, let's consider that one also. Systematic sampling can be regarded as cluster sampling of taking one cluster, here not from, should be from, right? Should be from. So it is a typo. So systematic sampling can be regarded as a cluster sampling of taking one cluster from k clusters of size n. So it is correct. It is correct, right? Because when we are considering the systematic sampling, normally what we do, first we calculate the sampling interval, that is k. Then we divide our sampling frame into k number of parts. From each sampling interval, we select one item. For that, from the first sampling interval, we select one item randomly. So that is called random start. Assume that the random starter is the first item in each sampling interval. Right? What in a random start එක තියෙනවනේ නේ. Random start එක හිතන්න එක. It means you have to select first element from every sampling interval. කියන්නේ හැම sampling interval එකකින්ම ඔයාට first item එක තමයි ගන්න වෙන්නේ. එතකොට ඒකේ ඉන්නේ first set එක තමයි ඉන්නේ නේ. sampling interval වල ඉන්න පළවෙනි කෙනාගේ set එක ඉන්නේ. Assume that instead of 1, you found the random start as 2. දැන් වාට එක නෙවෙයි ලැබෙන්නේ, ඊතන දෙක ලැබෙන්නේ. If it is 2, you have to select all the second elements in the given sampling intervals. දෙවෙනි කට්ටියගේ set එක තමයි ඔයාගේ sample එකට. So likewise, you may select third elements in each sampling interval or the fourth, likewise. So it means these are clusters. We can consider these sets as clusters. The may clusters may තියෙන sets ටික නේද මේ කණ්ඩායම් වෙනවනේ. පළවෙනියෝ ටික, දෙවෙනියෝ ටික, තුන්වෙනියෝ ටික ඒ විදිහට මෙන්න මේ set එකක් ඔයාට cluster එකක් විදිහට හිතන්න පුළුවන්. Within the cluster there are n number of items. Altogether there are k number of clusters. Sampling interval ke size එකට ඔයාට clusters ලැබෙනවා. So based on your random starter, you select only one cluster. ඔයාගේ random starter එක වුණොත් මෙයාව select කරන්නේ නේ. ඔයාගේ random starter එක දෙක වුණොත් මෙයාව select කරන්නේ. So it is like a cluster sampling. So therefore, we can consider systematic sampling as a cluster sampling of taking one cluster from k clusters of size n. So that is the relationship between systematic sampling and cluster sampling. So in this question, the answer is also the fifth statement. Right. So if you have any questions, you can ask, right? Okay. We'll move to the next question. Which of the following statements is true? So here also you need to select the correct one. Let's consider the first one. The accuracy of an estimate is measured by the standard error of that estimator. The accuracy, right? Accuracy means how much close you estimate to the desired parameter. බලාපොරොත්තු වෙන parameter එකට ඔයාගේ estimate එක කොයිතරම් ළඟද? ඒක තමයි accuracy කියලා කියන්නේ. So normally we can measure the accuracy of an estimate not by using standard error, but by using margin of error. Right? So normally if we want to measure the accuracy means assume that your desired parameter is mu. Right? Mu දන්නවනේ population mean එක තමයි ඔයාගේ desired parameter එක. Then consider x bar as an estimator for the mu. හරිනේ? mu ට estimate එක විදිහට ඔයාට x bar ව consider කරන්න පුළුවන්. If your x bar is close to mu, then you say your estimate is an accurate estimate. වාගේ x bar μට ලං වෙනව නම් ඒ කියන්නේ වාගේ estimate එක accurate. එයා නිර්වද්‍යයි. So how can you measure the accuracy? So you know that in making confidence interval, there is a concept as margin of error. Margin of error කියලා concept එකක් තියෙනවා නේද? Normally we denote by simple d. This is margin of error. So using margin of error, we can measure the accuracy. If we use the standard error for x bar, what is the standard error? For x bar, standard error is sigma over square root of n. So this is the standard error for the x bar sample mean. So we can use standard error in order to measure the precision. Precision, not the accuracy. Precision means the difference between your estimate and expected value of your estimate. X bar minus expected value of x bar. So that is the idea of precision. So here, first statement is incorrect. Why? The accuracy of an estimate is measured by the margin of error, not by the standard error. So therefore, first one is incorrect. Then the second one, the variance of sample mean in sampling with replacement is smaller than variance of sample mean in sampling without replacement. So normally, if you are doing replacement, we need more time. We need more time mean our efficiency is low. It means variance is high. If we are doing sampling with replacement means we have to put again and again the same elements. නේද අපි ගන්න එක ආයි දමමින් අපි නියදීම කරනවා නම් sampling එක කරන්න එහෙම නම් efficiency එක අඩුයි. So therefore variance එක වැඩි. So therefore without replacement එකක තමයි variance එක අඩු. Not the sampling with replacement. So therefore second statement is also incorrect. Right? The variance of the sample mean. Yes. So in order to measure the precision, we use standard error. Right? In order to measure the accuracy, we use margin of error. In order to measure the precision, we use standard error. And in the second statement, normally variation here with replacement, here variance without replacement. So which one is the smaller one? Without replacement is the smallest. So therefore second statement is also incorrect. What about third one? In third one, it expresses the standard error of an estimator can be measured only in a probability sampling. Is it correct? Yes, it is correct, right? So normally when we are distinguishing probability sampling and non-probability sampling, we learn measuring the standard error of an estimator is an advantage of random sampling. Tapi inferential statistics කරන්න නම් අපි කියනවානේ random sampling කරන්න ඕනේ කියලා. ඇයි? මොකද random sampling කරලා තියෙනවා නම් විතරයි අපිට පුළුවන් standard error එක measure කරන්න. Probability base එකක් නැතුව error එක measure කරන්න බෑ. So therefore, we can only measure the standard error of an estimator if we only perform probability sampling or random sampling. Therefore, third statement is correct. Third statement is correct statement. Anyway, let's consider both fourth and fifth statements. In fourth statement, it says the failure to interview the units in the selected sample is an example for a sampling error. Sampling error. ඔයාලා sampling ගැන ඉගෙන ගන්නකොට errors දෙකක් ඉගෙන ගන්නවන්නේ. ප්‍රධාන වශයෙන් errors දෙකක්. Sampling error and non sampling error. නියදුම් දෝෂය සහ නියදුම් නොවන දෝෂයනේ. So normally sampling error occurs because of sampling. It means instead of studying the population, you are going to study the sample. The population එක study කරනවා වෙනුවට ඔයා sample එක study කරනවා. එතකොට මොකද වෙන්නේ? අර population එකේ ඔයාට measure වෙලා නැත්නම් population එකම observe කරා නම් ඔයාට ලැබෙන values උයි ඒකෙන් කොටසක් වෙච්ච sample එක observe කරාම ලැබෙන values උයි අතර වෙනසක් වෙන්න පුළුවන්. It is called as the sampling error. Except that error, all other errors, such as the error in this fourth statement, are considered as non-sampling errors. error එක හැර අනෙකුත් සියලුම errors අපි හඳුන්වන්නේ non-sampling errors. So here, failure to interview the units in the selected sample. Even we select a sample, we were unable to take responses from each and every respondent. So it is an error, but it is not due to the sampling. It is due to any other reasons. So therefore, fourth one is not a sampling error, it is a non-sampling error. So therefore, fourth one is also incorrect, right? හතරවෙනි එකත් වැරදි. Fifth one, the term capital N minus simple n is called the sampling fraction. Capital N divided by simple n. So actually it is not the sampling fraction, right? It is sampling interval. The capital N බෙදීම simple n කියන්නේ sampling fraction එක නෙමෙයි. Sampling fraction එක කියන්නේ simple n divided by capital N. මේක තමයි sampling fraction. Simple n අපි capital N ගෙන් බෙදුවම n එක sampling fraction. Capital N simple n ගෙන් බෙදුවම අපිට එන්නේ sampling interval. හරිනේ? අය නිසා මේ පස්වෙනි එක වැරදි. So therefore, third one is the correct one. Right? It is easy, right? You can identify the third statement as the correct one. Right. Let's move to the next question. 40th. Which of the following statement is not true? So here you need to select the statement that is incorrect. Let's consider the first one. Central limit theorem implies that the sampling distribution of the sample mean is approximately normal if the sample size is large. It is correct, right? Right? It gives the definition of the central limit theorem. Because when the sample size is large, the sampling distribution of the sample mean is approximately normal. හරිනේ නේද? approximately normal වෙනවනේ. ඒක තමයි central limit theorem එකෙන් කියන්නේ. එහෙනම් ඒක හරි. Second one, an estimator is said to be unbiased if its expected value is equal to the parameter being estimated. It is also correct, right? As an example, if we consider x bar, right, sample mean and its expected value, and it equals to mu, it means x bar is an unbiased estimator for the population mean, mu. හරිනේ නේද? x bar ගේ expected value එක mu ට equal වෙනවා කියන්නේ x bar කියන්නේ mu ට unbiased estimate එකක්. So it is correct. Third one, an estimator is said to be sufficient if it contains all the information in the data about parameter it estimates. So that is the idea of sufficiency, right? If particular estimator contains all the information regarding the parameter, it is the sufficient estimate. ඒක හරි. ඒක තමයි sufficiency කියන concept එක, right? Fourth one, an estimator is said to be a consistent estimator of a population parameter if it has the smallest variance among all the possible estimators of the parameter. Is it correct? The definition of consistency, or what is the idea of consistency of an estimator? It is little bit different. So actually, the idea in the statement 4 is not regarding consistency, but regarding efficiency. Efficiency, right? Yes, efficiency. So if we consider the efficiency of an estimator, it means among all the unbiased estimators, the estimator with the least variance considered as the efficient estimate. So what is the idea of consistency then? Consistency means, we can take an example. Let's consider x bar. X bar is an estimator for mu. හරිනේ නේද? x bar කියන්නේ population mean mu ට estimate එකක් නේ. ඒ විදිහට අපි ගත්තොත් අපි හිතමු x bar ගේ variance එක හිතන්නකෝ. x bar ගේ variance. If we increase the sample size n, අපි n ගේ අංකය වැඩි කරගෙන යනවා නම් n ව increase කරනවා නම් සාමාන්‍යයෙන් අපි denote කරනවා මේ positive infinity එකට අපිට ගෙනියන්න පුළුවන් නේද? සාමාන්‍යයෙන් positive infinity කියලා එකක් නැහැ. නමුත් අපි සාමාන්‍යයෙන් අපිට තියෙන විශාලම සංඛ්‍යාව හැටියට මේ පැත්තට යනවා නම් we say we are close to infinity. So n is close to infinity. What happened to the variance of x bar? Variance of x bar is close to 0. If we notice this property, when the sample size increases, the variance of the estimator decreases. Then we say particular estimator is a consistent estimate. අන්න ඒ වගේ අවස්ථාවකදී අපි කියනවා estimate එක consistent කියලා. ඒ නිසා so the fourth one is false. So normally, in order to select the efficient estimator, the first condition is to be unbiased estimators. Unbiased estimators අතරින් තමයි අපි variance එක අඩුම එක්කෙනා efficient එක්කෙනා විදියට හඳුනා ගන්න. Therefore, we need to satisfy both conditions, right? It means our estimators should be unbiased estimators first. Then we calculate the variances of each estimator and identify the estimator with the least variance, and it is the efficient estimator. Then the fifth one, so it should be a correct one, right? Because you find the incorrect statements, therefore others should be right. Yes, there is a question. So the definition given here, it is correct for efficiency. So actually no any definition for efficiency here. Here only we have the definition regarding the unbiasedness, then definition regarding the sufficiency, and the definition regarding the efficiency. But in the fourth one, they use the definition of consistency. So here we can't use consistency. We can use efficiency, and the possible means, so there is a word possible, right? Possible estimators means the property of unbiasedness is also there, right? So therefore, if you get the definition of efficiency, no any misleading things in that statement. And if we consider the fifth one, the standard or error of mean of a sample taken from a given population decreases as the sample size increases, right? It is correct, right? It is correct. So actually that is the concept of consistency. When the sample size increases, normally the standard error decreases. Standard error always decreases. So therefore, fifth statement is also correct. So therefore, we can identify fourth statement as an incorrect statement. Right. So that is about 40th question. Let's move to the next one. So actually during 4 to 4:30, I have a power cut. Therefore, suddenly I may disconnect it. So therefore, I have to shift my internet connection into another connection. For that, I need some time. So therefore, if the session is disconnected, you have to wait, right? Until I again join. Right. In the 15th one, here also you need to identify the correct statements. So there are 3 statements. Normally in your MCQ paper, you can find these type of questions, right? There are 3 statements as A, B, C, or P, Q, R. And among those statements, you may have to select correct statements or incorrect statements, right? So therefore, not like actually earlier questions. In earlier questions, you have to only know one concept or the theory regarding one state. Here you need to know whether the A is correct or incorrect, whether the B is correct or incorrect, and also C is correct or incorrect, right? Anyway, the statement A, it says the distribution of sample mean of a non-normal population will tend to be increasingly normal when the sample size increases, right? So it is correct. So actually it is the central limit theorem, right? We know that when the sample size increases, non-normal population or population with non-normal distributions tend to be increasingly normal or approximately normal. හරිනේ නේද? sample size එක increase වෙනකොට සාමාන්‍යයෙන් non-normal distribution එකක් තියෙන population එකක් normal distribution එකකට එනවා approximately, not exactly but approximate. So it is correct. Statement B, the standard deviation of the distribution of sample mean increases as the sample size increases. It is incorrect, right? So actually in the earlier question, there is a similar statement. Because when the sample size increases, normally what happens to the standard error? It decreases. Ne? Sample size එක වැඩි වෙනකොට, so if we consider x bar and its variance of x bar equal sigma squared over n. So what happened? When n increases, what happened? Variance x bar decreases. So it is actually there is an inverse relationship between the sample size and the variance. There is an inverse relationship. ප්‍රතිලෝම සම්බන්ධයක් තියෙන. variance එකයි sample size එක අතර. කියන්නේ standard error එකයි sample size එක අතර. So therefore A is correct but B is not correct. It is incorrect. Then the C, the mean of the distribution of sample mean is equal to the mean of the population. If we consider the x bar, that is sample mean, and its mean means the expected value of x bar. No? Mean means expected value. Both are same. So we know that expected value of x bar equal to mu. X bar ගේ mean එක කියන්නේ sample mean එකේ mean එක population mean එකට සමානයි, equal. So therefore statement C is also correct. Therefore both A and C are correct, not B. Therefore the answer is third one. Right? So you need to know each and every concept regarding three statements, right? Not like earlier cases. Then කලින් එකේ නම් හරි මේක දන්නවනම් හෝ වැරදි මේක දන්නවනම් කොට දාගන්න පුළුවන්. නමුත් මේකෙදි මේ statements තුනම ගැන ඔයාට අවබෝධයක් තියෙන්න ඕනේ. එහෙම නැති වුණොත් ඔයාට හරි උත්තරේ ගන්න ටිකක් අමාරු වෙනවා. Right. So the answer is third one. Next one. Which of the following statement is true about the T distribution? So likewise, Z distribution, T distribution is also an important distribution in statistics. So therefore you need to know the properties of the T distribution. Let's consider the first one. Statement A, the T distribution is symmetric about 0. So it is correct, right? දන්නවනේ T distribution එක නේද? T distribution එක කියන්නේ මෙන්න මේ වගේ distribution එකක් නේද? So it is also symmetric about 0. බිඳුව මැද තියෙන්නේ ඒ වටේට තමයි distribute වෙලා තියෙන්නේ. So it is a symmetric about 0. And also if we consider the normal distribution, so this is T distribution. If we consider the normal distribution, its variance is not much T1 for T distribution, right? Like Z ගේ variation එක ගත්තොත් නේද dispersion එක විසිරීම ගත්තොත් T තරම් spread වෙන්නේ නැහැ. T distribution එකේ spread එක ගොඩක් වැඩි. So therefore both A and B are correct. Both are properties of T distribution. When coming to the statement C, it says the T distribution with k degrees of freedom has a smaller variance than the T distribution with k plus 1 degrees of freedom. So actually it is incorrect, because we know that when the sample size increases, sample size increases mean normally what is the parameter of the T distribution? T distribution එකේ parameter එක මොකක්ද? සාමාන්‍යයෙන් අපි කියනවා මේ degree of freedom නේද? Degree of freedom. අර දන්නවා n-1 නේ. සාමාන්‍යයෙන් n-1. එතකොට n-1 n. එතකොට n-1 උත් වැඩි වෙනවා කියන්නේ n උත් වැඩි වෙනවා කියන්නේ එකම කතාව. So what happened when the sample size or the degree of freedom increases, variance decreases. එහෙනම් k degrees of freedom තියෙන T distribution එකක variance එකට වඩා k plus 1 degrees of freedom තියෙන T distribution එක variance එක අඩුයි. When the degree of freedom increases for the T distribution, variance decreases. So make අනිත් පැත්තයි වෙන්නේ. ඒ නිසා statement C is incorrect. So therefore you can clear that only A and B statements are correct. So therefore the answer is the third one. So normally in every year you can find a MCQ question in relation to T distribution. සාමාන්‍යයෙන් T distribution එකෙන් එක MCQ එකක් ගොඩක් අවුරුදු වල ඇවිල්ලා තියෙනවා. T distribution එකේ properties base කරගෙන. හරි. Right. Let's move to the next one. Right. So now we need to do some calculations, right? So in 70th question, we have to do some calculations, right? So let's first read the question. An estimate is required for the population mean of the width of metal bars with a margin of error of 0.1 at 95% confidence level, right? So at 95% confidence level with a margin of error of 0.1, we need to do the estimation. අපිට මෙතන estimation එක කරන්න කියන්නේ confidence interval එක 95% වෙන්න ඕනේ, margin of error එක 0.1 වෙන්න ඕනේ. It is known that the variance of the width of bars is 0.25 centimeters. Variance is known in this case, right? So it is an important information. The population variance is known and it is equal to 0.25. Then what is the sample size necessary to achieve these requirements? So you need to calculate the sample size, simple N, that necessary to achieve the above requirements. So make a ජනප්‍රිය question එකක්, right? In your MCQ paper, most of the years you can find this type of question based on the margin of error. Decide the sample size. So we can consider the concept of confidence interval in this kind of situation. So what are confidence interval ගැන මතකයේ තියෙනවා නම් මේ වගේ question එකකට උත්තරය ගන්න පුළුවන්. මම පොඩ්ඩක් මතක් වෙන්නත් එක්ක මෙන්න මේ confidence interval එක බලන්නකො මතකද කියලා. සාමාන්‍යයෙන් population mean, here population mean, so we need to do the estimation for the population mean. So therefore we know that for the population mean there is a confidence interval like this, x bar minus z alpha divided by 2 sigma squared over simple n square root x bar plus z alpha divided by 2 sigma squared over square root of n. Right? බලන්න මේක මතකද කියලා. This is equal to 1 minus alpha percent. So here at the middle you can find mu, because we need to do the estimation for the population mean. And here you can see I take sigma. Why? Because as the information in the question it gives, it is known that the variance of the width of bars is 0.25. So the population variance is known. So when the population variance is known, here we use Z distribution. If we don't know and the sample size is small, then we have to use the Z, not the Z distribution, we have to use the T distribution. So that is the major difference. Right. So based on this confidence interval, we can do the calculations. So here, what they say, confidence interval is 95%. So if you draw the distribution, first you need to right